indeterminate form is a form or an expression involving two functions whose limit cannot be determined solely from the limits of the individual functions. Which means while computing limits we arrive or have a form जिसका हम एक प्रिसाइज या एग्जैक्ट वैल्यू ना दे पाए उसे हम indeterminate form कहते हैं. As an example, if we have the indeterminate form of the type 0 by 0, then 0 over 0 का एक हम precise या exact value नहीं दे पाएंगे because we do not know its exact or precise value, then this form will be called an undeterminate form या indeterminate form. Now we have 7 indeterminate forms as 0 divided by 0, infinity over infinity, infinity minus infinity, 0 into infinity, 0 to the power 0, infinity raised power 0 and 1 raised to power infinity. The last 3 are called power indeterminate forms, while the first 2 are called fundamental indeterminate forms. The first 2 forms are so called fundamental indeterminate forms because the last 5 are simplified by first converting them to fundamental forms of the type 0 by 0 and infinity by infinity, and then they are solved by using the L'Hopital rule. Now the L'Hopital's rule for indeterminate form of the type 0 by 0 or infinity by infinity. If limit x tends to fx over gx is an indeterminate form of the type 0 by 0 or infinity by infinity, such that fx and gx are both differentiable functions within their respective domains, then limiting value of fx divided by gx equals limit of the derivative of the numerator divided by the derivative of the denominator. That is, if limit x tends to fx divided by gx is an indeterminate form of the type 0 by 0 or infinity by infinity, then limiting value of this function will be limit x tends to a derivative of the denominator divided by derivative of the numerator. We can say f dash of x or f prime of x divided by g dash of x or g prime of x. Kindly note that fx and gx are not differentiated as a single fraction but are separately differentiated as numerator and denominator. Now कुछ examples देखते हैं 0 by 0 form पे which will be solvable by L'Hopital's rule. But before going on to proceed with the L'Hopital's rule, we have to make sure कि limit x tends to a fx over gx is indeterminate form of the type 0 divided by 0 or infinity by infinity हो, तब ही L'Hopital's rule applicable है. Otherwise we cannot go through with the L'Hopital's rule. Now if we have limit x tends to 0 1 minus cos x divided by 3x square, पहले हम check करते हैं कि whether it is an indeterminate form or not. So it will be अगर x 0 को approach कर रहा है then it will be 1 minus cos of 0, cos of 0 is 1, so 1 minus 1 ऊपर 0 divided by 3 into 0 square which will be 0. So this is an indeterminate form of the type 0 divided by 0. So this is 0 by 0 form. That means limit x tends to 0 1 minus cos x divided by 3x square, which will be limit x tends to 0 derivative of the numerator divided by derivative of the denominator. So derivative of the numerator is 0 minus cos x की differentiation minus sin x divided by 3x square की differentiation, it will be 6x. So it will be limit x approaches to 0 sin x divided by 6x. Again अगर हमें इसका limiting value compute करना है then we have to check whether ये indeterminate form फिर से मत है. So it will be sin 0 अगर x 0 को approach कर रहा है sin 0 which will be 0 divided by 6 into 0. So it will be again 0 by 0 form. Thus Thus it is again equal to limit x approaches to 0 derivative of the numerator divided by derivative of the denominator. So sin x की differentiation it will be cos x divided by 6x की differentiation 6. So again check करते हैं कि whether indeterminate form है या नहीं. So x approach to 0, so it will be cos 0. Cos 0 is 1, so 1 over 6. That means indeterminate form avoid हो गई. So we can write this as it will be cos 0. अगर limiting value of use करें, so it will be cos 0 divided by 6, which means it will be 1 divided by 6. So example second, limit x tends to 0 1 minus cos x divided by x log of 1 plus x. फिर से check करते हैं whether it is an indeterminate form. So x approach to 0 1 minus cos of 0, so cos of 0 is 1, so 1 minus 1 ऊपर 0, so x approaches to 0, so it will be 0 into this whole thing again. Log of 1 is 0, so which means this will be 0 by 0 form, indeterminate form of the type 0 by 0. Then इसका limiting value क्या होगा? So it will be limit x approaches to 0 1 minus cos x divided by x log of 1 plus x equals, so it will be limit x approaches to 0 derivative of the numerator divided by derivative of the denominator. So ऊपर derivative of the denominator, so it will be 0 minus cos x की differentiation minus sin x divided by x log of 1 plus x. So x log of 1 plus x, so it will be differentiated by product rule, so x will be left out, so log of 1 plus x की differentiation 1 by x plus log of 1 plus x will be left out, so we'll be differentiating x की differentiation 1. So it will be limit x approaches to 0 minus into minus, so it will be plus sin x divided by x divided by 1 plus x plus log of 1 plus x. Again this is an indeterminate form of the type 0 divided by 0. So therefore again we will differentiate numerator and denominator. So sin x की differentiation cos x divided by x1 plus x की differentiation by quotient rule, so it will be 1 plus x whole square into 1 plus x into differentiation of numerator, which will be 1 minus x into differentiation of denominator, so it will be 1 plus 0 plus differentiation of log x, so it will be again 1 upon 1 plus x. So now we can again check whether indeterminate form has been avoided or not. X approaches to 0, so it will be cos 0 ऊपर 1. So 1 plus 0, so it will be 1, यहाँ पे 0, so it will be 1 here, plus 1 plus 1 plus 1, so it will be 1 divided by 1 plus 1, so overall इसका limiting value 1 by 2 होगा. Now our next example will be limit theta tends to 0 e to the power theta sin theta minus theta square divided by theta cube. But before proceeding with L'Hopital's rule, we'll first check whether this is an indeterminate form or not. Only then L'Hopital's rule is applicable. So if we check the condition, so theta tends to 0, so sin theta will be 0 minus theta tends to 0, 0 minus 0 divided by 0 cube. So it is an indeterminate form of the type 0 by 0. So L'Hopital's rule is applicable. So therefore by L'Hopital's rule, so limiting value will be limit theta tends to 0 derivative of the numerator divided by derivative of the denominator. But e to the power theta into sin theta, so it will be differentiated by product rule. So e raised power theta will be left out, sin theta की differentiation cos of theta plus sin theta will be left out into e to the power theta minus theta की differentiation 1, theta square की differentiation 2 theta divided by theta cube की differentiation 3 theta square. Now again we will check whether the indeterminate form has been avoided or not. So e to the power theta into cos theta, so this will be 1, this will be 0, 1 minus 1, so it will be again 0, divide maybe 3 into 0 square, so it will be 0, which means it is again an indeterminate form of the type 0 by 0. That means we can again apply L'Hopital's rule. So it is thus limit theta tends to 0, ऊपर से फिर प्रोडक्ट रूल e to the power cos theta पे और sin theta e to the power theta पे फिर से L'Hopital's rule, बट यहाँ पे डिफ्रेंसिएशन होगी बाय प्रोडक्ट रूल. सो e to the power theta as it is cos theta के डिफ्रेंसिएशन माइनस sin theta प्लस cos theta will be left out, e to the power theta की डिफ्रेंसिएशन e to the power theta प्लस sin theta की डिफ्रेंसिएशन as sin theta as it is e to the power theta की differentiation e to the power theta plus e to the power theta will be left out, sin theta की differentiation cos of theta minus 1 की differentiation 0 minus 2 theta की differentiation 2 divided by 3 theta square की differentiation 6 theta. Again we will check whether this is an indeterminate form or not, but before proceeding we will first try to simplify this. So it will be e to the power minus sin theta, यहाँ पे e to the power sin theta, but that is plus, so it will cancel out. E to the power cos theta, so that means it will be limit theta tends to 0 twice e to the power theta cos of theta minus 2 divided by 6 theta. फिर से चेक करते हैं कि whether indeterminate form has been avoided or not. So when theta tends to 0, so this will be cos of 0, cos of 0 will be 1, so 2 minus 2 which will be 0 divided by 6 into theta which will be again in 0 by 0 form. Therefore we can again apply L'Hopital's rule, so which will be limit theta tends to 0, इसकी फिर से differentiation 2 will be left out, e to the power theta as it is cos theta की differentiation minus sin theta plus cos theta as it is e to the power theta की differentiation e to the power theta minus 2 की differentiation 0 divided by 6 theta की differentiation 6. Now we'll check whether the indeterminate form has been avoided or not. So theta, when theta tends to 0, so sin theta it will be 0, so 0 into this whole thing it will be 0, cos theta will be 1, so it will be cos theta 1 into e to the power theta, so it will be 2 into cos of 0 into e raised to power 0 divided by 6, which will be 2 into 1 divided by 6, so it will be 2 divided by 6 which is 1 by 3. Now next example is limit a tends to b a to the power b minus b to the power a divided by a to the power a minus b to the power b. Kindly note that here this a will be treated as a variable and this b will be treated as a constant. So first of all we'll check whether this is an indeterminate form or not. A b को जा रहा है, so it will be b to the power b minus b to the power a, b को जा रहा है, so it will be b to the power b minus b to the power b which will be 0. So again b to the power b minus b to the power b, so this is an indeterminate form of the type 0 divided by 0. Thus we can simplify this by L'Hopital's rule, which will be limit a tends to b derivative of the numerator divided by derivative of the denominator. But here a is variable, so that means we have to differentiate numerator with respect to a and we have to differentiate denominator with respect to a. So we can write this as d by dA of a to the power b minus b to the power a divided by d by dA of a to the power a minus b to the power b. We can again write this limit a tends to b d by dA of a to the power b minus d by dA of b to the power a divided by d by dA of a to the power a minus d by dA of b to the power b. Now we have to find derivatives of all these terms. Now we have to find the derivatives of 4 terms here. We'll be finding derivative of variable to the power constant, variable to the power constant, constant raised power variable, constant raised power variable, constant to the power constant, and variable raised power variable, variable raised power variable. So first of all, if we had to find derivative of a to the power b, so we can write d by dA of a to the power b, which will be equal to, so since a is variable and b is constant, so it will be variable to the power constant. We know d by dx of x to the power n, where x is variable and n is constant, it will be n times x to the power n minus 1. Thus a is variable and b is constant, so इसकी differentiation होगी b into a to the power b minus 1. Again d by dA of b to the power a, since b is constant and a is variable, we know d by dx of a to the power x, where a is a base which is constant and x is variable, so इसकी differentiation है a to the power x log of base, which is log a, which means since b is base and a is variable here, so it will be b to the power a into log of base, so log of base, b is base here, so it will be log of b. Again d by dA of a to the power a, so d by dA of a to the power a, since a is variable, so it will be variable raised power variable, this term variable raised power variable. So we have to find the we know derivative of x raised to power x. We differentiate this by logarithmic differentiation. If we write u is equal to x to the power x, then taking log both sides, so log of u equals x log of x, so differentiating both sides with respect to x, so log u will be 1 by u into du by dx, x log x को प्रोडक्ट रूल से सॉल्व करेंगे, so it will be x into log x, ये differentiation 1 by x plus log x will be left out into differentiation of x, which will be 1, so it will be x से x कट जाएगा, so it will be 1 plus log of x, which means du by dx is equal to u times 1 plus log of x, u का value x to the power x, 1 plus log of x, which means d by dA of a to the power a, it will be a to the power a 1 plus log of a. Now lastly d by dA of b to the power b, since b is constant raised power constant will be again a constant, so इसकी differentiation होगी 0. इन सभी का वैल्यू यहाँ पे रिप्लेस करते हैं, so we'll be obtaining limit a approaches to b, so d by dA of a to the power b, which is b times a to the power b minus 1, b times a to the power b minus 1 minus d by dA of b to the power a, it is b raised power a into log of b divided by d by dA of a to the power a, so it is a raised to power a into 1 plus log of a minus 0, so which will be limit a approaches to b times a to the power b minus 1 minus b raised to power log of b divided by a को अंदर multiply करते हैं, so it will be a raised to power a plus a raised to power a into log of a. Now I guess the indeterminate form has been avoided, so अब a को b से replace करते हैं, so this will be b times a को b से replace करेंगे, so it will be b times b minus 1 minus b times a will be b, so it will be b times log of b divided by b raised to power b plus b to the power b log of b. So it will be ऊपर b raised to power b raised to power b raised power b minus b raised to power b log of b divided by b raised to power b plus b raised to power b log of b. So ऊपर b to the power b common, नीचे भी b to the power b common, so it will be b raised to power b 1 minus log of b divided by b to the power b 1 plus log of b. So b to the power b will be cancelled with b to the power b, so it will be overall 1 minus log of b divided by 1 plus log of b.